What is the most important thing our society needs?
Oh, world peace. Definitely world peace. That's easy. World peace. Peace. World peace. I think we should educate America's children with the knowledge of 1D kinematic equations and their properties and purposes. Here, let me show you.
Miss New Jersey has brought us to her high school track, and with the help of her friend, Miss New York, she's going to educate us and you viewers at home exactly what 1D kinematic equations pertain to. Let's watch.
Hello, America. I'm Miss New Jersey, and I'm here at my own high school track to formally show you why, if I win, I will strive to educate high school students about 1D kinematic equations. I want to thank Miss New York for helping me demonstrate. Here's how it's going to go. First, I'm going to ask Miss New York to sprint from one end of the track to the other. Miss New York, are you ready? Yeah!
The difference between final and initial velocity is that the initial velocity is associated with the velocity that the object has at the beginning of its motion, and the final velocity is the velocity of the object at the end of its motion. Time is simply the amount of seconds in which it takes the object to complete the motion from beginning to end.
Thanks, Miss New York. Alright, viewers, 1D kinematic equations deal with the speed, initial velocity, acceleration, final velocity, time, and displacement of an object or person at motion. Speed refers to how fast an object is moving. Velocity is defined as the rate at which an object changes its position. Acceleration is the rate at which an object changes its velocity, and displacement is how far out of place an object is.
Let's say that Miss New York's initial velocity is 0 meters per second, because she starts at rest. Assuming she has an acceleration of 0.5 meters per second squared, the time she took to run from one end of the track to the other was 15 seconds. Let's find her final velocity. Her final velocity is 7.5 meters per second squared.
Constant acceleration is most often known as being used in freefall problems.
This is what the graph would look like for constant acceleration.
Constant velocity means that an object must have constant speed in a constant direction.
This is what the graph would look like for constant velocity.
That wasn't hard, but Miss New York isn't done helping us yet. Miss New York isn't only a beauty pageant queen, she's also a talented cheerleader. Now she's gonna help us perform a tumbling pass. Go!
My initial velocity before I started running was at 0 meters per second. I traveled 7 meters before the start of my tumbling pass. My acceleration was roughly 3.5 meters per second. With this information, we can now determine my final velocity. We would use the formula final velocity squared equals initial velocity squared plus 2 times acceleration times displacement. The result is 7 meters per second.
So, Miss New Jersey, exactly why do you think learning about 1D kinematic equations would benefit our society today?
Well, Mr. Clark, people don't realize that motion is a part of our everyday life. We all have to walk at some point during our day, and some of us might even have to run, too. We are constantly increasing or decreasing our velocity without even acknowledging it. If society becomes aware of the impact of these factors, we can educate ourselves with basic physics that contributes to our everyday life. This can also help society furthermore understand how to raise their performance while performing physical exercise if they know the certain factors of the equation.
Thank you, Miss New Jersey, for providing the beauty pageant lovers with some physics knowledge today. Let's head back to the studio where other participants are waiting anxiously for the final results. I have the final results in my hand, and the winner is Miss New Jersey.
Oh my God, thank you so much, thank you. I hope to be coming to your school next year to teach your students about 1D kinematic equations.
Educate us, and you viewers at home, exactly what it was. Jersey.
No, it's already. Show me the thing. She's also a talented cheerleader. Now she's gonna perform what is it?
A tumbling pass.
A tumbling pass. Okay, we're gonna also a talented cheerleader. Now she's gonna perform a tumbling
Tumbling pass!